In this lesson, we are going to learn the third method for solving quadratic equations called formula. But before we start, let's just review a bit. We previously learned about the basic lines like y equal x, and then the general form of a line is y equal kx plus b. It's 1 degree. And for parabolas, the basic equations are y equal x squared. So its general form would be y equal ax squared plus bx plus c. And we could even go further for basic cubic functions. It's y equal x squared. And its general form would be ax cubed plus bx squared plus cx plus d. And now let's just focus on its general form of quadratic equation. So an equation like ax squared plus bx plus c equals 0, we have a formula for it to solve its roots directly. The formula is x equals minus b plus or minus b squared minus 4ac to the power of 1/2 over 2a. You can just simply substitute the value of a and b and c to solve the roots, and it's quite simple. And let's try an example. X squared plus 4x plus 5 equals 0, and let's apply the quadratic formula. And to be clear, let me just write the value of a and b and c. So a corresponds to 1 because it's 1x squared. And you should remember, a, b, c, or k in the future you're gonna see, these are all constants. You just don't know the value of constant, but they're still constant. And as for x, y, z, t, normally they appear as variables. They're not only unknown, but they're also changeable. They are variables. So the difference of variables and constant, you should focus. And so the value of a is 1, and the value of b is minus 4, the integrity. And the value of c is minus 5. And let's just plug those values into the formula. So x would be minus 4, which is 4. So plus or minus 4 squared minus 4 times 1 times -5 over 2 times 1. You can just plug those values and then count them, and this would be its roots. And then let's just go on. So its numerator would be 4 plus or minus 16 plus 20 over 2. And inside the index, it will be 36, which is 6, because 36 to the power of 1/2 would be 6. And then let me explain this minus and plus sign here. It means it has two roots. One is 4 plus 6 over 2, and another is 4 minus 6 over 2. So its two solutions, its two roots would be 5 or minus 1. So see, quadratic formula is quite easy and clear. You can just correspondingly write or read values of a or b or c and plug them into the quadratic formula. It's all done. And let me write it again. X equals, you can just try to memorize it, minus b plus or minus b squared minus 4ac to the power of 1/2 over 2a. And you can try to solve another equation, x squared minus x minus 2 equals 0. Still, or you don't need to do this when solving the equations on paper, but just to be clear, let me write the value of a and b and c. So a corresponds to 1, and b is -1, c is -2. And let's plug those values. Ax equals 1, because minus 1 is 1. 1 plus minus squared minus 4 times 1 times -2 over 2. So x equals 1 minus or plus 9 to the power of 1/2 over 2. So x equals 1 plus 3 over 2, or x equals 1 minus 3 over 2. So it will be 2 or minus 1. And that's how we apply the quadratic formula. So this method has only one main requirement. You see the formula here. X equals minus b plus or minus b squared minus 4ac under the power of 1/2. You see here. You got a third here. So we call b squared minus 4ac as discriminant. You see, now we haven't learned imaginary numbers. So -1 under the power of 1/2, -2 or -3, they don't literally exist right now. Or they don't exist in real numbers. And now we're learning real numbers in this page. So we have a precondition here. B squared minus 4ac, which is called discriminant, it must be greater or equal 0 to have a root. Otherwise, if it's smaller than 0, you won't have a real root, which means under this page, the root doesn't exist. And we could split the situations of the green one into two. So if the discriminant b squared minus 4ac equals 0, you see, so it will be minus b over 2a. It will only have one root. Or to be more precise, it has two roots, but they are repeated, so it has two repeated roots. And if the discriminant is greater than 0, you have two distinct roots. And if it's smaller than 0, you have no real roots. Remember here is real roots. It actually has two complex roots if you learn imaginary numbers, but we haven't learned so we can just take it simple as no real roots, which is no roots for the knowledge that I have learned right now. And some of the books even take this as delta, but I think delta isn't a common used symbol here, so we can just take it as discriminant. Discriminant is the most accurate and the most common used. And I think this will be everything in this class. And I need to cover a harder study materials, that is the deduction of the quadratic formula. And if you're a really good student and you have good comprehension, you can just go. Otherwise, you can just skip the rest of the materials. So let's just try to solve this equation by completing the square. So how do we deduce the formula? Well, first, for completing the square, if the number here is 1, it will be way much easier for us to find the constant plug-in. So we can just take a out. So it will be a outside the bracket. So it's x squared plus b over ax plus c over a equals 0. And here we have a 0 on the right side, so we can just cancel a. And this is how we write this. And for changing it into quadratic formula, for changing it into the perfect square, we need to plug a value here. So we see x squared plus b over ax, and we plug in these values, b over 2a squared and minus b over 2a squared, and plus c over a. And so this middle part could be rewritten as x plus b over 2a squared. We can change it into the squared form, and we can remove the constant on the right side of the formula. So it will be b squared over 4a squared minus c over a. And then we could combine them together, which would be b squared minus 4ac. And so in order to solve this equation, we can cancel the power of 2 by putting a third on the right side and minus or negative, plus or negative, because we just canceled a power of 2. But we have a precondition here. You see, if 4 squared is definitely bigger than 0, but if the numerator is smaller than 0, we cannot cancel that power. So that's why we're defining the discriminant. So here we have a precondition. B squared minus 4ac, it must be greater or equal to 0. And here's how discriminant comes. And after canceling the power, we can just remove b over 2a on the right side. So it will be 2a minus b over 2a plus or minus 4a squared, b squared minus 4ac. And then we could cancel the power here as well. We can just take them separately on both numerator and denominator. And for the denominator, it will be 2a. And we can combine them together as 2a over minus b plus or minus b squared minus 4ac to the power of 1/2 over 2a. So this is the quadratic formula. We basically deduce it from the general form using completing the square. And it's very useful to memorize the quadratic formula. You can use it anywhere. Of course, if you are taking some exams, it can also be found in the booklet. But I still recommend you to take it down and to memorize it. So I think this would be everything in this class, and I hope you could learn this method very well because it's very functional. And think briefly, how do we fully and accurately represent a parabola on a coordinate plane? And that will be what we're going to be covering next class. And thank you for watching, and see you next time.